Okay, thank you. We're back for a bit of maths now. I understand you've just been into an assembly all about books. Hopefully you've enjoyed that. Does mean today's maths lesson is going to be a little bit shorter than normal, but I'm sure we'll still be able to pack lots of useful learning in. So over the last few days then, we've been thinking all about perimeter, haven't we? And so we're going to be thinking a little bit more about that today. We're going to try to move that learning on a little bit more with some problem solving today. So first of all then, let's think about this question. Which calculations will calculate the perimeter of this rectangle? The reason that we're thinking about that is because there's multiple ways of doing it, isn't there? There's lots of different ways we might have for finding out the perimeter of a rectangle like this. So pause the video and have a bit of a chat with the person next to you about how you would do this and which of these four actually would be able to tell us what the perimeter of this rectangle is. Okay, well, hopefully you've had a chance to discuss that amongst yourselves. We know, don't we, that the perimeter of an object is the length all the way around the outside. So important to note, first of all, that even though there's only two measurements there, even though there's only the 5 centimeters and the 2 centimeters, the answer isn't 7. The reason it's not 7 is that's only those two sides, and actually we need to work out the other two as well. Now, we looked earlier in the week at the fact that because the one on the top, for example, is 5 centimeters, we know the one underneath it has to be 5 centimeters as well. It's the same length because it's the same size. Same for the other two sides as well. On the right hand side, we've got 2 centimeters. That means the one on the left must be 2 centimeters as well. So which of these would actually give us the right answer then? Well, 5 plus 2, we've already ruled that out. That wouldn't work because that wouldn't be adding up all of the sides. B though, 5 plus 2 plus 5 plus 2, well, that would work, wouldn't it? Because that would be adding up all 4 of the sides. So that one would give us the perimeter. What about C? 7 times 2. Now, where have they got the 7 from? It's from adding up the 5 and the 2, isn't it? 5 plus 2 is 7. And why have they doubled it? Well, it's because that we'd also need that same measurement again for the other 2 remaining sides. So yes, 7 times 2 would work as well. So 14, our answer there. 5 times 2, no, that's not right for the perimeter. We don't need to multiply the numbers together for our perimeter. There is another calculation we might do where we do times, but that's not something we're going to be looking at today. That would be area, which we will think about a little bit, but that's not going to be something we'll learn too much about right now. Okay, so we've worked out that it can be B or C. Okay. So what about the perimeter of this rectangle? Now, is it 52? No, because that's only 2 sides. Well, does that mean it's 104? Can you pause the video here and have a quick discussion about why it's not 104? Well, the reason that the perimeter here isn't, sorry, the reason it's not 104 is because right now we've got 2 different units of measurement, haven't we? We've got a mix of millimeters and centimeters. So let's do a bit of converting first of all, so we've all got the same units of measurement. We said it's not 52 and it's not 104. Could it be 7? Could it be 14? Let's have a think. Let's do the converting first of all. So we know that 50 millimeters, well, that's the same as 5 centimeters, isn't it? 5 centimeters. So is it 7 centimeters the perimeter, or is it 14? Well, even though it's only 5 and 2 that we can see there, we do also need the remaining 2 measurements. So we'd need 5 and 2 again. So it's this person that's correct. It would be 14 in this case. Now, we're going to be doing some work today in our maths books where we've got our useful centimetre squares. Here is a rectangle with a perimeter of 16 centimetres. Firstly, do we agree with that? Has this got a perimeter of 16 centimetres? Can you just double check that for us now? Is that true? Let's count up our edges. We've got 6 along the top. We've got 2 down the side. So that adds up to 8 once we've got our top and side. And then, of course, we double that for the rest. So that is a perimeter of 16 centimetres. That's right. Now, on the inside of that, that's filled up 12 squares. So the perimeter was 16. The space inside that shape was 12 squares. I wonder if every rectangle with a perimeter of 16 centimetres has 12 squares inside. Let's check out some other ones. So checking out this one, we've got 1 centimetre by 7 centimetres. So that's definitely got a perimeter of 16 still, but that's only 7 squares. On this one, we've got 1, 2, 3, 4, 5 by 3. So again, that is a perimeter of 16 because 5 and 3 is 8, double to make 16. This one has 15 squares inside it. And over here, we've got a 4 by 4 square, and that's got 16 squares inside it. Now, we're going to be testing this out now. I want you to see what you can spot when doing this yourselves. Now, once you've got your date and title written down, I'd like you to have a go yourself at making as many different rectangles as you can that have a perimeter of 18 centimetres. I want you to find which one has the smallest number of squares and which one has the greatest number of squares. So like we saw a moment ago, we can draw different shapes that have the same perimeter, but shapes that have a different number of squares on the inside. And I want you to explore that in your book. So draw as many different rectangles as you can with a perimeter of 18. And I want you to find for me the rectangle with the smallest number of squares inside and the greatest number of squares inside. If you're feeling really confident there, a bit of a spicy challenge is going to be, can you make a generalizable statement about that? So what I mean by that is, can we say, right, well, when I do this, that's when I get the greater number of squares. When I do this, I get fewer squares. So try and write a sentence underneath if you feel like you've got it, that you think demonstrates actually why some rectangles have more squares in the middle than others. So pause here, have a go at that, and then come back for the second question in just a moment. So you're back here with me now with Tiny the Turtle, and we're going to be having a go now at the second challenge for us today. And this is based on Tiny's statement here. He says, you can't draw a rectangle with an odd perimeter. Is he correct? Now, you might have an answer in your head already, but what I'd like you to try to do is to challenge your own ideas and to actually try to test it out. So you might be thinking either the answer is, oh yeah, it's definitely yes, or maybe, oh no, the answer is definitely no. But can we have some outside the box thinking here? I wonder if anyone can come up with a rectangle that has an odd perimeter. Could you try maybe having 2 odd numbers as the lengths around the side? Could you try having 1 odd and 1 even number as the 2 lengths? Could you try 2 even numbers? Is there another way we could do it to get an odd perimeter? Let's see. So remember, the perimeter is the length all the way around the outside. So give that a go and come back and let's see if we can find an answer to this. So pause the video here Have some time exploring in your books and see if you can come up with the answer to Tiny's question. So, was Tiny correct then? Well, most normal rectangles would have an even perimeter. Doesn't matter if we've got two odd numbers, an odd and an even number, two even numbers, you're always going to get an even perimeter if we're using whole numbers. We'll come back to that in a moment. The reason for that is it doesn't matter if you double an odd number or double an even number, you will always get an even number once you've doubled it. If you put two odd numbers together and two even numbers together, you're always going to get an even number as your total. But I wonder if anyone found the exception to the rule. Did anyone try it? You could make a rectangle with an odd perimeter by using halves. Did anyone have a go at this in the classroom? I'd be really impressed if you did. Did anyone think outside the box a little bit and try to do ones like this? We've got 4.5, for example, by 3. Well, we could get there. We could get a half number, because if we add a half and a half, well, then we are going to get an odd number, aren't we? If we add a half and a half, we're going to get 1. Super. Hopefully you had a good go at some of those challenge questions today. So once you've packed your maths books away, it's going to be time for a little bit of quiet reading before lunch. And make sure, please, nice and quiet in the classroom. I'd love to hear that everyone's been reading really quietly. Thanks, everyone. Enjoy your lunch, and we'll see you back later on for our topic lesson after lunch. Thank you.